Hey, it's Mr. Love here again. This is part 2 of 2, QUIZ2-5. This is the backside of that, the circular motion problem. The problem reads, David's favorite ride at Busch Gardens, the rotor, which has a radius of 4 meters. The ride takes 2.5 seconds for David to make one full revolution. The key part to this problem is really the most important thing here is deciding what this piece of information is, and it helps you solve everything else within the problem if you do that correctly. So if you look back at your definitions for frequency and period, this description matches up with the period. So looking at section number 1 or problem number 1, the period, which is t, is simply given in the problem, and that's 2.5 seconds. Sometimes they give the frequency, sometimes they give the period. This problem happened to give the period. You need to know how to decide which is which. The units tell you. So this is seconds, that's period. If it were per second, that would be frequency, or frequency per second, or hertz would be frequency. So in order to find number 2, which is the frequency, it is simply 1 over the period, or it can be expressed as period to the minus 1. So that is simply 1 over 2.5 seconds, and that equals 0.4 per second, or 0.4 hertz. Okay, number 3, rotational velocity. If you check back at your notes, the definition for rotational velocity is pretty much the same as the definition for frequency. So because this is 0.4 seconds, it's actually 0.4 revolutions per second. So 0.4 RPS, revolutions per second. Number 4, the tangential velocity. We define tangential velocity as v equals the circumference, 2 pi r over the period. So that equals 2 times pi. The radius is given in the problem. I didn't write it up here, but the radius is given. That's 4 meters. Defining the variable is always important. 4 meters over the period, which is 2.5 seconds. Solve that algebraically, so that's 2 times 3.14 times 4 equals, you divide that by 2.5, and you get 10. And the units for velocity is meters per second, meters right here over seconds. Number 5 asks what the objects are David's centripetal acceleration. That's AC equals v squared over the radius. So we just solved for v, so that's 10 squared, or actually 10 meters per second. 10 meters per second squared divided by the radius, which is 4 meters. You solve that algebraically, so that's 10 times 10, that's 100, divided by 4. So the centripetal acceleration is 25 meters per second squared. Okay, and number 6, which is the last part, it says what is the centripetal force that is exerted on David? And centripetal force, Fc, is simply the mass times centripetal acceleration, or if you want to solve the whole thing, it's mass times velocity squared over radius. Just be careful that you don't use acceleration here, because that's v. So the simplest way to do it is plug in the mass, which again should have defined the variables up front, but looking back at the problem, it says that his mass is 60 kilograms, so the mass is 60 kilograms. Scroll back down here. So centripetal force equals 60 kilograms. 60 kilograms times 25 meters per second squared. Centripetal force is equal to 1,500 newtons times kilograms. I'm sorry, that's actually the wrong thing. The units should be for this 1,500 kilogram meter per